All right, let's not hold up the show any longer. So welcome to Thank Data Thursday. I'm your host, Patrick Byrne. I'm a Tableau Community Manager. Today we have Tableau Zen Masters Hall of Fame member Jonathan Drummey. Jonathan's going to take us through this Thank Data Thursday on how can I know my numbers are right, validating data, calculations, and joins in Tableau. And without further ado, I'm going to hand it over to Jonathan.
All right, thank you, Patrick, and welcome everybody who's watching it live and everybody on video. Just to set out just a ground rule on this, you have, there's a chat and a Q&A. I prefer if you use the chat just for asking questions. I'll be monitoring the chat as we go, but if I miss the question, I'll try to answer it at the end. So, and with that, I'll also start my video. So here we go. So we're going to talk about data calculations and joins in Tableau. And so one question I start out with my audiences with is like, how many of us have actually had significant formal training in data analysis? And in most of the audiences I speak with, that's like maybe 5 to 10% of the audience have had real thorough formal training, and a lot of us haven't. And when we start using Tableau, that can lead us down different routes. So I'm one of those people who didn't have formal training, but I have had informal training from women like this. So back in the 1990s, I was working with data from phone companies, and phone bills back then were itemized. So every single phone call would be charged, maybe as a second, tenth of a minute or a minute rate, with a lot of different variability. So even just calling to different parts of the town that you lived in could get different rates. And people who are older and retired and unlimited incomes would be in, sorry, a little distracted by the chat. So they'd have time and motivation to go through their bills to make sure everything added up to be just right. So in me working on billing systems, I had to make sure all the numbers came out right and had to build out a set of skills in doing that I'm hoping to share some with you today. So that was working on phone bills. Nowadays, my work is at PATH. PATH is a non-governmental organization working around the world in projects involving maternal and child health, childhood vaccination, HIV treatment, and malaria elimination. And Patrick, I'm going to jump in. I'm seeing some questions about slides, people saying intending to show something different than the title page.
Yeah, so it doesn't look like your PowerPoint is going forward in the Zoom meeting here. Are you?
It's going forward for me. Let me try.
Possibly try unsharing and resharing real quick.
Yeah. Okay. Share desktop.
And this is proof it's a live webinar, folks.
All right. Are you seeing it now?
Not yet.
I'm not. Gotta love webinar technology.
Yep.
Yeah, now we're just getting a blank screen.
Okay. Since we're supposed to be looking at Tableau and it's a data visualization tool, not having screen sharing is a little bit of a challenge. I'm just going to stop my video. Maybe that'll help with some of the bandwidth here. And this did work when we did the tech check earlier. Seeing anything right now?
No, it's still coming through as a black screen here.
Okay, I'm gonna do something here. Stop sharing. So yes, everybody who's, there's a question, everybody who's attending is muted right now. All right, how about now?
No, not yet, Jonathan.
Yep, still not coming through.
Okay, I'm gonna pop in and out of the Zoom and just see, because I've done multiple different options of stuff here. So I'll be back in just a moment.
Yeah, sorry about this, folks. Some slight technical difficulties. Hopefully we'll be back up and running in just a second here.
All right, I'm back. And I will share my desktop.
Hey, there it is.
There it is. Okay, so Zoom got a little confused. All right. So I was talking about path, doing these different things, including malaria elimination, which is what I mostly work on. And we just had a little announcement today that I'm super excited about. So Tableau, Mapbox, Exasol, and Alteryx. Today's World Malaria Day around the planet. And these 4 companies, which have been part of the Visualize No Malaria project that I've worked on, have announced a grant today of $4.3 million to support our work. So it's more licenses, more training, and everything to support the work that I do. And a big thank you all to everybody at Tableau, Mapbox, Exasol, and Alteryx for this. And also all of you who are customers who are in helping these companies have the money that they can commit these funds to projects like Visualize No Malaria. So there'll be more press releases and stuff on that through the day. All right. So you may not be so interested in malaria or some of these other things. So I'm going to give some examples about why we should care about our numbers being right. So in this case, this comes from a real world example where I was given a data set that had about $2.5 billion worth of grant data, being told that that's what was in the data set. And switching over to Tableau here, and I'm just going to go to my disbursement data. All right, there's my mouse. And then if I just take out that budget number, and I'm just going to drop it on rows right now, there's $3.2 billion worth of budget in this data set that we were told was $2.5 billion. So something's up there. Or another example, going back with a little dashboard from Superstore. So here we are, built this little dashboard, and I want to see how many orders there were for customers. So I'll pick on Dublin. And so I can see like Carla had 20 orders, Randy had 10 orders, and then using Tableau's Vision Tooltip feature, I can pull up what those orders are. And then when I hover over this for Randy Carpenter, it says he has 10 orders, but I'm only seeing 1, 2, 3, 4, 5, 6 orders here. So 10 and 6 don't line up. And there's something wrong here in this, in what's going on. And this comes to a thing of when we look at like this tent here on the right, it's failed, but we can't see the point of failure. We just know that it's failed. And it's the same way in these views that I just showed. Something failed, but we don't know exactly what went wrong. So there's a chunk of this session that's about figuring out what it is that went wrong and how to avoid that in the first place. And with this, this is kind of one of the key takeaways with working with Tableau is that we're changing up the modes that we're working with Tableau. So there's this place of what Tableau was designed for, was this exploration of our data, where we can point and click, we can drag and drop, double click on things, click around and show me, and every time we do that, we're seeing our data change and shift, and we're seeing a new view of our data and gaining insights from that. And that is, it's fantastic in what we can do in Tableau. Now, there's this other thing of when we're starting to build calculations or do joins or things like that, staying in that exploratory mode won't get there. So we need to be more of an engineering mode. So for example, I've got the Golden Gate Bridge in the background here. If I just took a pile of concrete and a pile of steel and cable and everything and tried to throw together and put a bridge together, I could probably build something that looked like a bridge, but it wouldn't necessarily stand up to wind or waves or earthquakes or the traffic on it or things like that. Whereas if I understand engineering principles of material science and friction and tension and things like that, then it can build a bridge that will last for decades. So when we're switching into doing things like working with calculations in Tableau, doing joins and so on, we really need to shift our mindset from exploration to more of an engineering mode. So I'm going to go through some of those principles that are involved here. So, and the piece with this, in doing this, is we don't necessarily have to be writing a ton of code and everything, because Tableau's mission has been help people see and understand their data. So we're going to use Tableau as a tool for data visualization to help us work through these issues around calculations and joins and so on. Today's tips are going to be in 3 areas. And understanding grain of data, creating and validating calculations, same for joins. This is something that we could spend a multiple day training on, and I'm trying to feed you as much as I can in the next 40 minutes or so. So it's going to be a bit abbreviated, but hopefully enough to really get you going. So the first place we start out with is understanding the grain of your data. So we can think of different data sets, and the things we put in our different data sets as having different sizes. So I could have a customer as something that I'm tracking, or it could be the individual order item for that customer. So the SKU that they order or something like that. So one could be a very coarse grain, another could be a very fine grain of data. And so we're asking this question, my data has a record or a row for each something, and that something could be a customer, an order, a transaction, patient, malaria case, and so on. And so we want to find the grain of that data. And so we're going to read the documentation, if there is documentation. Sometimes there's not. We're going to form a hypothesis about what that data is, and then we're going to test that hypothesis using Tableau. And we need to do this before building views and dashboards. So these 2 problems that I showed earlier over here in Tableau are both problems where our idea of what the grain of the data is not the way the data actually is. So our mental model of the data and the data as it is actually expressed are 2 different things. So we need to understand the grain of the data to validate our mental model. So to do this, we're going to fill in this sentence. I expect to have a record for each something. And we're going to identify the fields in the data that represent whatever that object is. And hopefully they will be unique. So to do that in Tableau Desktop, we can start out looking at the data grid, and very often in data sets, the leftmost columns will help us identify the data, or if I'm looking at a data set of orders, an order ID might uniquely identify a row in the data. We're going to add a worksheet, put number of records on color, and I'm going to demonstrate this, not just talk about it. And then we'll put discrete dimensions on rows until we get a record for every mark. And then we can use view data to help us see those underlying records and see differences. So the first example I'm going to do of this is going back to this view. So I have 10 orders here in my number of orders measure, and I'm expecting to see that many down below. So if I start out with the Superstore grain here, I'm going to take number of records on color. So I can see in the color legend readout, I've got 9,274 records in this version of Superstore. And then I'm thinking I've got my customers out there on the view, so I'll put customer name on the view. And then at this point, there's 2,770 marks in the view, 2,770 rows by one column. So I've got 2,770 customers in this view, and I don't have to scroll down or do anything. I can just look at the color legend to see I've got between 1 and 22 records for each customer. And then let's bring out order ID, because I thought order ID was going to uniquely identify my my orders here, and it turns out I have more than one record per order for each customer. So I've got between 1 and 5 records for each order per customer just by looking at this. So in building the view and assuming that the grain of my data was an order for each customer, that mental model of my data was incorrect. The data actually looks like this. And then I can do a view data and look down here and see in the full data, I've got different categories for different customers. There's different products that they ordered and so on. And that's what's creating those different records. So that's one example of this. Now this relates to this question of count and count distinct and sum of one, that these are all aggregations that we do on the data, and each of these three has a different definition. So here I have a data set. I'll just do a view data on it. It's a very simple one that I set up with 9 rows of data. So we've got product here, so product A and product B, and each product has different sets of colors. So A is red, green, blue, blue, and null. B has red, green, blue, and purple. So now if I take color out and I just do color, we can see the different colors for these. And if I count the colors, so I'm just going to bring this over to text, and I will right click and change it to a count measure. I see 4 and 4 here. So the definition of count is we're counting the non-null values of color. So if I view data here and I go to full data, I'm counting the red, the green, the blue, and the blue, but I'm ignoring the null. So that's that 4. Now I'll do a right click and drag or alt click and drag on the Mac to drag this out to show me. I get my drop field, I drop the count distinctive color. And now we can see I've got 3 and 4 here, different values. So I'll just right click, view data, look at that full data, and now we can see for A, I've only got 3 distinct colors that are not null, red, green, and blue. So that's what the distinct count is doing. And then if I take some number of records, I'll just add that to measure values. This is counting the number of records in the data, and this is returning 5. So we've got 3 measures here, count, count distinct, and sum, that are returning all different values. So when we're looking at data, we've got to think about how do I want to be aggregating this data to get the numbers to come out right. So I just want to do one more demo of this in desktop to kind of try to settle in with Superstore, and we're just going to go all the way down to 1 record per order, having talked about this difference. And I'm just going to close my Safari here so I don't keep on landing on that. So here's Superstore. This is a slightly different version of Superstore. It has 9,426 records in this. So in this version of Superstore, if I drag out order ID, Now I have between 1 and 6 records for each order, and I can do that view data and full data. And then in here, as I'm scanning across this, I'm looking for things that are different. So I have product category, I have product name, which is kind of lower level than product category. So let me look at that. So let's put out product name. And now I have one record for each combination of order ID and product name across the whole data set. So now I've identified the grain of the data. It's order ID and product name in this data. I could also, there's potentially other multiple ways you can uniquely identify a row. So if I do some number of records on color, and there's a row ID in this version of Superstore, and if I drag row ID out, that's showing, again, 1 for everything. I don't have to look down or do anything like that. I just know, because this is some number of records, it's going to return 1, at least 1 for every single record in the data. So this data set actually has two ways to identify the grain. Order ID and product name is one way, row ID is another. So this is validating the grain of data in Tableau Desktop. In Tableau Prep, it's a little different because Tableau Prep works differently. So what we're going to do is, once we connect to the data, we add a clean step. Then we're going to use the profile pane to identify columns, and we can potentially use the histogram in the profile pane to see that. And then we're going to do an aggregation of the data, which is doing that same thing as some number of records and dimensions. Is just in Prep, it's an aggregate step. So going to Prep here, I will start a new flow. And I'm going to connect to an Excel file. Here's the same Superstore I was just using. It's got a bunch of tables in it. And I'm just going to take orders out. So here's my orders table. And I will add a step just to see what's in this file. So I do have that row ID. And if I switch this to looking at detail, so this is, because row ID is numeric, it's binned the values and put them in here. But if I do detail, then I can see I've got 1 row for each row ID. And if I look in this histogram view, there's nothing that sticks out. So this is one way to identify grain of data. Now, the other way we can is I'm going to add an aggregate step. I'm going to take that number of rows here and drag that out to aggregated fields. So there's that 9426 that we saw. And then here's my order ID. I'll drag that onto the grouping. And now we can see there's between 1 and 6 rows for each order ID. And then I can take out that product name as another example. And now some number of rows is 1 for everything. So I've done the same thing as in desktop, but in Tableau Prep, and kept myself in the flow here as I've worked with it. So that's Tableau, doing a demo of Tableau Prep. So there's this question of, okay, when do we need to check the grain? And it's every time we're connecting to a new data source, we're joining a new table, we're changing the data source in some way with filters or joins, or we get, if we have a source that hasn't shown themselves to be fully trustworthy, whenever we get an updated file of this. So I'll do an example of this that I recently had. So here, somebody got me a data set of, this is from Kitete district in Zambia, and they had joined some data. So they had coordinates in one source, their measures in another source, and they're like, I want to plot them on a map, and all they get is 1 mark for the whole province. And in fact, every facility is having the same latitude and longitude. So something wasn't working with this. So the place to start with this that they didn't do is check on this grain of the data. So here I have some number of records. There's 17,000 records here. And so my expectation would be I have a record for each facility, and month in my data. And it turns out we don't have that. We've got 33 records for each facility and month. And then when I do a view data on this, go to that full data, I can now see I've got facility here, and then here's my facility from my coordinates file. And they're not there, or this one matches, but then there's all these other ones that are replicated throughout. So if I look at this one and do a view data, we'll see the same thing. We're seeing this facility coordinates here. So this is a case where the join actually caused us problems. Right at the beginning, if I look at the join here, the join is only on the district and not the facility. So that caused a problem there. And I could have gone down a route of trying to diagnose what was going on with the latitude and longitude and stuff like that. And the problem was way upstream as a bad join, and going back and looking at the grain of the data, or starting with the grain of the data, lets me spot that. So we're always checking the grain at different times. So going to this grant disbursement data as another example of this, on this data, so in the documentation for this data set, I'll just put number of records here in color. We've got 87,000 records in this data source. So in this example, I was told that all of these fields marked 0 marked the grain of the data. And then I'll just do the alt-click and drag to drop this as a discrete pill. And there's between 1 and 230 records for each of these. And rather than try to find which ones are that, I'm just going to show filter on this. So this is another piece of diving in to figure out what's going on with the data. And using Tableau as a visual tool, I'm just going to change this to 2. So now I'm showing everything with between 2 and 230 records. And then I'll just right-click on one of these and do a view data and look at the full data. And then I'm going to start looking right here. And the only thing that's different between these two rows in the data is one has a budget of null and one has a budget of 0. So at this point, this is a situation where I've been told what the grain of data is. I can't validate the grain of data, and therefore I need to talk with the people who gave me this data set to fix that. And there's some different reasons why that might happen. There might be missing columns in the data set that would identify that grain, or maybe there were bad joins upstream. Sometimes data just doesn't have a unique key, or the data doesn't have the structure that I'm expecting. And this is fairly common as we're working with Tableau. So I have a data set here that I downloaded off the internet of water heights from the Hoover Dam. So if I look at this data, we have, for each year, there's columns for each month in the year, starting with the year Hoover Dam opened and then continuing on the way down. So this is a perfectly usable data set. We see these all the time in Excel. But if I'm working with this and I want to look at like month over month changes in the data or something like that, it's possible for me to build out a line chart with this data. If I do something like I'll put measure names on columns, measure values on rows, let's get rid of that number records one, and then start rearranging the pills here so everything's alphabetical. So this is kind of a sign that the structure of the data is not matching my mental model, because if it was matching my mental model, it would most likely be very easy to use. So the thing we can do in Tableau, I'm just going to duplicate this data source, and I'll edit it just to show it. And here I'm going to select all of these columns and then do a pivot. And now the data source is matching more of my mental model of I have a record for each year and month. And then from there, building for each year, here's my pivot field names, here's my pivot field values on rows, make that a line chart. That's just a few clicks to actually get that. So I've been talking about mental models along the way. So, and oops, that's a little typo here. This should be your mental model of the data has to match the data structure as it is. If not, then you're going to have a hard time later. The numbers are going to come out wrong at some point. And in my case, where the numbers that we're working with are about people getting malaria treatment or not, people getting HIV meds or not, it's literally life and death for these people. So we really want our numbers. Let's talk about creating and validating calculations. So as a kid, I played with Lego, and I really like the Lego instructions because they give us these small steps that show us here's what we did, or here's where we start with, here's what we did, here's what we're doing in the next step. And there's a chance as we go in each step of the way, if we make a mistake, to identify exactly where we went wrong. Because it's much better to identify where things went wrong up here than way down there at the end. So the kind of archetypal example of this with Tableau is using profit ratio. And so if I build a calculation, and I'm just going to show this one right here. So I take profit divided by sales, and I'm going to look at this by subcategory. And then here's my profit ratio. I'll just put that on columns here. And I can see I've got profit ratios between negative 100,000 and 100, close to 150,000. And these just seem really absurdly huge profit ratios, especially if I take my sum of profit and my sum of sales here. So I have 224,000 in profit divided by 767,000 in sales. That should be around something around 25% or so, and instead we're getting negative 23,000%. So something clearly went wrong here. So when you run into this, ask for help. If you're not paying attention to this, you'll be keeping consultants in business. So these are a whole lot of workbooks I've helped people with over the years. And in a lot of cases, what I saw was people doing things like this where they built out a ratio calculation, they dropped it into a view, so being in that exploratory mode of working with Tableau, and the numbers were wrong and they were stuck. So we want to slow things down with this. And these steps are, number one, we want to define our calculation in plain language. If we can't write it out for ourselves in plain language, we're going to have a really hard time telling the computer what to do. Then we want to break down those parts and then build out the parts starting with record level, then aggregate, and so on. And if you're not familiar with that, I'm going to talk about those terms in a second. And then we're going to validate each part as we go in workout views, repeat those steps until we're done, add any remaining filters to the view, and then we can duplicate that sheet, workout sheet, which is kind of a known good sheet, to build our final view. And then we can be more in that exploratory mode as we're just dragging and dropping calculations that we know are working right. And this is something that we're already used to. So in Excel, if we start out with a data set, and then I can do something like add a column to the data set so that I can then throw it into a pivot table, and then I'm going to write a formula to get my average of those different numbers. We're doing this in this very incremental step-by-step fashion in Excel. And so we already have skills, most of us, in building out calculations like this, and we can do the same thing as we're working in Tableau, that we can take our data, do some sort of transformation on that data, see that in a workout view in Tableau, and repeat, and so on. And Tableau Prep already does this because of its flow-based model, so I'm not going to spend much time on Tableau Prep for this, more on Tableau Desktop. So these are these small incremental steps. And just to talk about this piece right here, what I mean by these different parts, I'm going to do a little demo. So my mouse keeps on vanishing on me for some reason. So with these 4 levels of calculation, I've taken Superstore. Let's look at profit, and let's look at profit over. So I've taken my raw data at this point, and I've now aggregated those 9,000 rows to 1 mark for my profit. Then I'm going to take it to order date. So now I've aggregated them to 4 marks for the 4 years, and now out to 16 marks for years and quarters. So we can see this down here in the lower left, the 16 marks. Now I'm going to do a quick table calculation on top of this, year-over-year growth. So now I've taken those 16 marks and turned them into 12 marks for my year-over-year growth. So I've done a calculation on top of the sum of profit. So it's a 3rd level from the raw data to the sum of profit to the year-over-year growth. And then here, this you already dropped in an average line for me. So this is the average of my year-over-year growth. So that's a 4th level of calculation that I got through point and click and drag and drop. So I'm not seeing all those intermediate steps that we see back in something like this. I do them all point and click, which if we're really sure what we're doing is fantastic. When we're building things out, we need to slow down a little bit. So in Tableau, we have these 4 different pill types. And these pill types show us the levels of calculation. So if we're seeing just the name of the field on the pill, that's a record level value. If we're seeing an aggregation keyword on that, then it's an aggregate, so our 2nd level of calculation. And then if we have the little table calculation icon, that's our 3rd level of calculation. So, and I numbered these 1, 2, 3 because this is the order in which Tableau processes them in. It computes all of our record level values first, then our aggregations, then our table calculations. So going back to our profit ratio example here, when I initially did that profit ratio wrong, I'll just drop this on my ABCs, Tableau is computing the profit ratio at a record level, and then it is summing it up in the view. So at a record level, if I do a view data, look at my underlying data here, this profit ratio wrong is being computed for every single mark and then getting summed up to the view. And if I took all of these marks here, copied them out, pasted them in, they'd add up to all of that. So the thing we want to do in thinking about this order of operations is that I actually want to sum up my profit and sum up my sales, and then I want to do my division. And that's what this profit ratio accurate is. So I'm thinking about the order that I want the computation to happen in and making that a little more conscious than I might have had to otherwise. And so I have my sum of profit divided by sum of sales, and I'll bring this out, and that is 29.23%. So yeah, just under 30% of that, and so on. So this is a piece where we need to think about what level we're looking at in Tableau. So Tableau is separating the raw data, which we can view in 3 different ways. If we view data in the data grid, if we right-click and view data, or we can build a view that has data at a certain level, and in this case, I'm at a much higher level, or if I understand the grain of the data, then I can break out those dimensions into the view that will let me identify that record level value and work with the data as it exists. So having this understanding of what is the grain of my data, what are the dimensions that define that grain of data, and then what level I want my calculation to work at, all that up for us to get our calculations right. For time, I'm going to skip this one on incidence ratio. And these are the steps. So this is what I do most every time, and I can say, having helped thousands of people answer questions about Tableau, the times when I don't do this are the times when I get confused myself. So it is going a little slower, but it's getting us accurate results. So now I'm going to talk about creating and validating joins. So when working with joins, there are 4 outcomes of a join. We can end up with fewer records than we expect. We can have more records than we expect. We could have the right number of records, but they're not what we're expecting those values to be in those records. Or maybe everything works. as expected in those joins. So in building joins in desktop, we're again taking smaller steps. So the process here is, first of all, we're going to define our join in plain language. And again, just to understand what is it we're trying to do here. And in some cases, this will also help us define whether we need a join or a union. Then we're going to create a data source in Tableau and connect to what I call table A, or what will be the left side of the join. And then we're going to check the number of records, the grain of the data. We're going to look at our join keys and see how much of the join we can do just visually looking at it. And then we're going to do the same thing for table B. And then we're going to create a third data source, connect to those two tables, and build the join as a full outer join initially, so we can see everything that fell out of the join. And again, we will do all of that checking on that to validate that we get it all working right. So I'll do an example of this in Tableau Desktop quickly. A little bit. So here I have a data set of malaria data. So I've got 324 records in it, pretty simple data set. I've been told the grain is facility and month, so I will look at the discrete exact month here, and I can see that yes, I have one of each of them, and my facilities are named 1001 up to 1009. So all that looks good. Now we'll look at my population data that I'm going to join on. So 27 records in this data set, so a smaller number. Here's my facility numbers. So I've got 9 facilities here, not starting at 1001, going back and looking at this one, but starting at 999. So visually I can already get a sense that I've got stuff not matching. And then here's years in this data source. So I don't have months in this, I have months here and years here. So in building out a join, I'm gonna have to get that to work right. So then I can just actually duplicate this source now. I'm gonna edit my source, and then I'm gonna add a connection to my population data. And then here's my Siavanga population, and I know I can join on facility on both sides. I'll do a full outer join on this one. And then I need to join on month and year. And those are two different things. Tableau's throwing up this error at me. So in this case, I can create a join calculation and do year of month here, and then do this join. I'm seeing 327 rows, and then I can take my merge data set. Let's put number of records on color. There's my 327. Here's my initial data, facility, and month. So I'm seeing a null value of facility there, which is actually coming from this facility 999, and let's just make this discrete here. And now I finally identified the grain of this data. As a full outer join, this is what it looks like. And then I can choose, maybe I want to work with this, maybe I want to exclude these results, maybe I want to change my join type, and so on. So this is how we build joins in Tableau Desktop. For prep, it's kind of a similar thing, only we can do more of this because Tableau Prep was designed for data preparation. We can do it inside Tableau Prep. So we're going to connect to A, connect to B. If you are connecting with a database, Tableau can suggest fields for you. And then we'll repeat those as we go. So switching over to Prep, I'm just going to open up my Siavanga start. So here's my malaria data. For time, I'm not going to go through the looking at the grain of the data. Here's my population data. In this step, I'm going to take my month and I'm going to create a calculated field so I can build that year calculation. to join on. There's my different years. Now I can just click and drag to build that join. So Tableau Prep automatically picked up the year in the join. Then I can do facility to facility number as another one. And in the Prep interface, I can see what's falling out. That I have facility 1001 doesn't exist in here, and then I have facility 099 that doesn't exist here. And I can choose how I'm going to work with this data. So for example, I can do a full outer join and then keep all of these. And along the way, each of these is clickable, so I can see those unmatched rows from the join results and browse them down in here and look at what goes with what. So this is my favorite part of the Tableau Prep interface, is being able to review this very easily and identify what I need to keep. So sometimes, this is just the last example I'm going to do here. So one of the things when we have multiple clauses in Tableau Prep, it can require us to do more cleansing of the data. So this is an example. So I have a data set. This is Mozambique districts. And we have Mikufi here that has an accent on the U, and then we have Mikufi that doesn't have an accent on the U. So it's not falling out. And then the Pemba Matuje has a dash and doesn't have on this side. So that we'd have to fix in Tableau Prep's interface, we'd have to do this fix 3 times to get the join to fully work. The workaround in this case is we can go to an upstream clean step and make one change and then have everything just work. So that is one thing where, as much as we can do in that join step, I find it easier in Tableau Prep to do more of that cleansing in the clean step upstream. And then some common join mistakes. So I'll see people using an inner join way early in the process, like going back to the example I had with the map here, that somebody had set up an inner join and then they just weren't seeing everything that was going on in the data in that case. So that's one thing that can happen. Also, when you're not joining on all the join keys that you're expecting to show up, you want to be careful as you're working with multiple join clauses, because it's going to connect everything, the exact values of all the combinations to the exact values of all the combinations. And you might try some simpler joins just to see everything work there. And also be checking your underlying data and look at those join keys just to see that those values are what you're expecting to see. And then with joins, because they're so often, they need to be super exact, so no extraneous spaces, no extraneous accents, etc. We need to make sure they match exactly to figure those out. So just to quickly review, we talked about understanding the grain of the data, a brief bit on creating and validating calculations, and validating joins. And the tip through all of this is we're going a little slower and working with the data step by step in this kind of view right here. So with that, I saw a few questions came in and I will pop those up and look at those. So can we get the slides after the webinar? Yes, I will post them. MySQL does not allow a full outer join on this. Yeah, so thank you to whoever sent out the bit. So you can emulate a full outer join with a couple of joins in a union. Okay, so those are all the questions there. Do we have any questions in the Q&A? No. So are there any other questions that are coming in? So question, when you point data at new sets, will the join clauses remain? So I'll just take Tableau Prep as an example. So I have this flow. If I save this flow, then, so this part of the definition of this flow is it's pointing at this sheet 1 file that is in this connection. If I edit this connection to point at a different file, it's going to save all the steps of the join and everything. However, this data changed, then that could break the join, of course. So that's one definition of new data set, where I have a new data set that I'm swapping out a file. Another definition of new data set would be that I just have new data in the same file. And in that case, Tableau Prep or Tableau Desktop happily opens that up and just works with it. The third definition of this is we have a new data set and we're going to connect something else and add it to this. So if I click on this one, like if I drag out my chicken cotta table here, then the piece that I'm looking at is I really have this data set, my Siavanga data set. I have a data set coming of the join between these two. And then I'm adding a fourth data set of this chicken cotta raw data. And then when I go to join that in, I'm then creating a fifth iteration of the data set. And so we want to be validating each step of the way that we're getting the results that we expect out of that. So hopefully that answers your question, Anne. And for Regis, thank you. Yep, that's the goal of the presentation. I will mention something else in here. If you haven't seen it in Tableau Prep, another favorite feature I have in Tableau Prep is you can right-click at any point and choose Preview in Tableau Desktop. And then you can get, so what Tableau Prep will do is it's going to run the flow up until this point, generate a hyper extract, and then, oh, I've got an error in the flow. So it won't let any errors at all be in there. So I'm just going to remove this step. Then I'll preview it in Tableau Desktop. And Tableau starting up here. And then we can get a drag and drop experience within Tableau Desktop on this to look at our data. So there's times I'll do that when I have data with a ton of fields, things like that here. Oh, there were some Q&A questions that just showed up here. People wanting to see, I'll just answer this one first. Can we join between Tableau extracts and SQL Server tables? Yes, we can. So in Tableau Prep, we can connect to a data source. We've got Tableau extract as an option in any of these. And as long as Prep can connect to it, we can join, we can aggregate, we can union, etc. And then Paul, keyboard shortcuts I've been using. The main one I've been using is right click and drag or alt click and drag to get the drop field. Otherwise, I don't think I've been using too many. If you spot them and want me to know or want to know them, ask me. Where do I draw the line between using Prep and Tableau for data preparation? For this one, for me, the line is pretty much, if I go back to Tableau Desktop here, if the join doesn't work in Desktop first time, pretty much for the thing I suggest users who are, or I'll make a division between users. If users are kind of newer to working with data and doing joins and things like that, if the join doesn't work perfectly in Desktop, I point them towards Prep because Prep has much better tools for validating joins. So for example, in Prep, I'm going to go to this one with the join calculation. edit my data source. So I built out a join calculation here. There is no way in Tableau Desktop at this time to see the results of that calculation, of that join calculation. So Tableau is computing that as part of the building join, and there's no outfield output of it. So if that calculation was incorrect in some way, returning nulls that were unexpected or returning unexpected values, I'd only get to see that secondhand through the results of the join. So what I actually do to build out join calculations is I'll build them out in my original source. So if I go back, into Tableau here, in the Siavanga data, I would build a view to validate that join calculation. And that's a lot of extra complexity, whereas Tableau Prep, because it has this flow-based model, we can build that calculation, validate it, and then use it in the join really easily. So that's my, my Prep versus desktop argument. And then Prep versus Alteryx is a, what's the word I'm looking for? So in this, there are programmatic operations that we want to do on the data that we can't currently do in Prep. There's also R, if we want to run like R Python code in our Prep flow, we can't do that in Prep right now, but we can in Alteryx. Also, Alteryx has a whole suite of spatial tools that Prep does not. Alteryx has also been around since like 2000 or something like that. So in that, there's things I've tried to do in Prep and things I've tried to do in Alteryx that just work in Alteryx and don't work in Prep, because Prep was officially released 1 year ago yesterday, I just found out. So thank you, Amanda, for letting me know about that. So that's kind of that. At the Tableau conference last year, they did some interesting demos and things. So we're going to see some changes along that way for Prep, and it's going to be able to handle more. So Jennifer Hunter had a question on any thoughts on what could be going wrong when a count given ID that you are 100% positive is unique and some number of records would return 2 different results. I'm going to go back to this sheet right here, is that if you're seeing something like this, then your data is not what you think it is, and you need to investigate your data to look at that. So understand what the grain of that data is to see what's going on there in that. And if you have questions, feel free to post something on the forums and ping me. You can do at Jonathan Drummey on the forums and on the Tableau community forums, and I will take a look. So that was that one, and I answered that one. So has the advent of Hyper changed the way I join or work with data, or pretty much the same? On this, I'd say it's pretty much the same. As we've used before, the bigger thing that has changed in my work is Tableau support for spatial data, because most of my work, everybody wants to see things on a map. And so having native support in the tool for spatial data is really awesome. And I'll do one last check on the chat, see if anything else came in there. And Paul Benoob on the chat had put out a list of keyboard shortcuts from that. So thank you, Paul. All right, so we're at time for this. So I'll let you all get back to your days. Thank you for attending. I hope this was useful to you. And let's just see if I had any last slide here going on that.
Well, thank you, Jonathan.
Yep.
It's been an excellent presentation. Just some housekeeping items for people. We will have this presentation posted to our YouTube channel. You can also see all of our other past Think Data Thursdays at the YouTube channel as well. So feel free to stop in there. And also you can check out the link that will be updated in the community post as well, which Jonathan also mentioned that he is willing to help anybody with additional questions if you want to tag him in the community. All right, well, thank you, everybody. Jonathan, did you have any other last things you wanted to touch on before we go ahead and end the session here?
I would say one thing to do is just, if you learn something here, try it out, share it with other people. And thank you.
Awesome. Well, have a good day, everybody.
All right, bye.